Hello, everyone. My name is Liang Yan. I'm here to give you a session about enable VGPU in Firecracker. And I'm really excited to do this presentation here. Enjoy. So before we start, I'll just give you some introduction about myself. So I'm a virtualization engineer from SUSE. So my working area is mainly focused on the I/O virtualization, GPU, and network before. And architecture mostly focused on ARM64 and S390, the non-x86 architecture. And also, as you know, SUSE dropped OpenStack Cloud last year and purchased Rancher this year. So we had some transition. I started working on the Firecracker here, and I like this stuff. And also, I work at home for 4 years now. I know most of you are also working at home because of the coronavirus pandemic. I hope you can enjoy your work at home timing. And I live in Louisville, Kentucky, United States. So usually people don't know it. I just say this is the hometown of Abraham Lincoln. People still don't know it. Then Muhammad Ali, maybe still. Then I said just Kentucky Fried Chicken, KFC. Now they know it. So sounds like people enjoy food better than sports, better than politics. Anyway, this is just a joke. So let's back into today's topic. So for today, I'm going to give you a quick background about the micro-VM Firecracker here, and also give you some introduction about GPU virtualization, especially some latest update, and also the motivation. Why do we want to do it? And how do we do it? What should we do? Since this is a journey, exploration journey, so I'll share some thoughts after that. So at last would be the QA part, but you can type in your question from our platform, the chat platform. So I would be glad to answer. So let's have a quick look on the micro VM here. I think it's not a strange for you guys, and for me, I also followed this topic for a couple of years. There's a lot of a couple options here, like QEMU Lite, QEMU Lead, NEMU or QEMU Macro VM from last year. This is QEMU based, and Firecracker, rust-vmm based, but it's earlier than rust-vmm. Anyway, and also some other like process level, the API, like a GWiser here. So it's not my intention here, so we just keep it. If you look at those VMs here, you may see something in common, like they are not considered as a VM, but more like a container, and they also work as a container. There's only like maybe one workload under it, and a very short life cycle, and just need it is safe, and the architecture is light, the running is fast. Here's architecture for Firecracker. You could see it's highly integrated with container here, and I think that's the main usage for them too, for the micro VM. And we'll take a quick look to the GPU side. So I think everyone using GPU today. But looking at the GPU, you may see there's two mainly uses for it, graphic and computing. Graphic like the game streaming, 3D rendering, and computing is more like popular today because of the AI machine learning, and you know that there's two different types for this kind of machine learning. The training, train a model based on the huge data sets and the inference. Like you already have this trained model, just do some judgment. So, and then the GPU virtualization. And I think a lot of people already done this topic from a low level. And we couldn't know that, like you can see pass-through, GPU pass-through, that's a basic one. And there is also a full GPU virtualization. And there's a soft way to do it, MDV, mediated device, Intel and NVIDIA doing it. There's a hard way, like SRROV, and AMD did it. But NVIDIA is also jumped to it too. And ARM also, so you can see here. This is the 800, just announced this May. And you can see there, this called multi-instance GPU actually are SRIOV based. And one interesting part is that it could also be used for a CUDA application directly. So, and a user case is like you can use it in a container. So looks like all about container today. And ARM is pretty new, and they just announced its GPU virtualization solution last month, I think. And interesting part is its user case. They are mostly used for vehicle autonomous driving, and basically for this automotive enhancement. And this is a new user case besides the training and inference scenario there. And it's kind of interesting, make things. Anyway, so they also have, and based on the architecture here, it also looks like hardware based. And yeah, there's also other GPU. I've been working very closely with all those vendors in SUSE, like the NVIDIA, ARM, and also AMD, Intel, and even some other hardware accelerator like FPGA and neural NPU, like TPU, some stuff there. So, but we are talking about the GPU here, so let's just focus on here. And now comes to the motivation. Why do we want to do it? Like, I guess generally because people want it. It's quite popular for AI and machine learning today. And some people just want more from Firecracker. Like, yes, you are wonderful, but why don't you provide this more? The other side is about the GPU virtualization. Like we could see that I/O virtualization is actually become more powerful now, and it has its own virtualization capability, and which is independent with the general VMM. And like we just saw the 800 there, like you could just use its VGPU for application. So that's a good case. And also people are talking about it in Firecracker, the GitHubs here, like copies here, and generally people want it, but there's some conflict here, like because Firecracker has its specific purpose, mainly for the serverless computing. And so in this case, they may need to run tons of workloads in a host. In that case, they want the oversubscription, and also they want a better performance during the workload switches. And VGPU virtualization seems not good. But anyway, I'll still show you how to do it here. Like I said, I just new to Firecracker and rust-vmm stuff, but I know VGPU and also QEMU. Good part is that most of its work is still reused. like the host side MDV or SROE, and is created for the VGPU, and we share this. And the KVM side, Firecracker is still using KVM for it. So those parts we don't need to care about. And we only care about the vfio-mmio, the part, like if we're using the vfio PCI pass-through, basically vfio-mmio just needed to create a PCI device based on the host information by like accessed by vfio function here. And the other part is that Cloud Hypervisor, this is a project based on rust-vmm. It implemented vfio binding and the vfio-ioctls. I think that makes the whole process much easier, doable. From here, the vfio binding is kind of some header files automatically generated by the binder gen. And you can see there are just some header files for the function definition from the KVM host side. And the vfio-ioctls is the mainly implementation. So now things get clearly and easier. So what I did here, as I said earlier, I'm working on the GPU virtualization. So I have a lot of fancy hardware here, the VGPU V100, NVIDIA V100, Intel GPU, and I also have this old AMD GPU here. And I'm working on based on the 315 SP2 OS here, and also running the vfio-mmio. So I from my thought, I think I needed to run through with the Cloud Hypervisor. That would make things easier. Like if it could work, and if not, what's the problem? After that, I can just backport or refactor to the Firecracker. So things are pretty clear. And during my try on Cloud Hypervisor, I found most of them could work, only like a VGPU. It's like once I parsed the MDV inside, it couldn't get through. So looks something wrong with the GPU driver during my debugging. But I'll follow that later. But anyway, I mainly use the Intel VGPU here because it's open source from either side. And now back to all these, like I checked how Cloud Hypervisor make it work. And in order to that, I need this kind of crease here, the vfio binding and the vfio-ioctls. This is the two main creates here for implementation, and also need a PCI. As you know, Firecracker only has this MMIO bus. So we needed to implement this PCI bus there, and then just some vfio-mmio, like we needed to follow the whole process and then implement in Firecracker. And also need some dependencies like the VM device manager, and the VM locker, and the full PCI implementation. I probably moved much more code here because I just, as the first step, I just make it work. Then I can get through all the code carefully. And also there's some other things, like because of the GPU, the specific of the GPU, we need some of the UEFI for some of the VBOS set up. Otherwise, it will have driver issue later. And also the kernel configuration. The original configuration is quite simple, and but we need to enable extra modules for just to enable the graphic driver. So, and yeah, I I planned to put all the code here, but well, that's really not necessary. And if you do that, you may see another benefit for the Rust is like the whole device create. It's much easier than the QOM model back in QEMU. So what I'm doing here is like during the Firecracker, I parse the parameters here. I just catch this device comes with the path of the device. Like if you use the MDV, it will come the UUID number, and also if just the virtual function, it would be just the PCI numbers there. And then during the VM initialization, I needed to create this PCI bus, and then I needed to use the vfio to create PCI devices. So I needed to access the host device with the device path or ID, you can see. And then it will access to the host sys file system and get the grab and device information from host. And then you just use this information to create your vfio PCI device. And after that, you put it to the PCI bus. And after that, I think it will be detected by the guest VM. So far, even I said I think I put much more code here, but it could work with some basic functions, and it could be detected by the guest kernel. Although just during the kernel, the driver couldn't work very well. There's a lot of issues like here, the bus table is not available, can't find this one, and a lot of DRM function failures there. The DMAT is kind of a mess. I'll need to go through that anyway. So anyway, like I said, this is a journal explore. So let me just share some thoughts during here. Like during all the Backport working, I think it's fun. I like to reading code. So, but I just feel like during all the working, I'm just one question I'm keep asking: is it a good fit? Because first, the more I Backport, the more it needs. Like I needed to Backport this, that, and even after that, the Firecracker looks quite different. The booting time and the memory footprint, it's bigger, and I must have done something wrong. Also, like during the discussion there, so the issues there is still exists, like the design philosophy of authorities computing, like since there will be a lot of workload here, and so they want this oversubscription, and they also want the switch would be fast and efficient. However, the VGPU scheduler probably would be a concern. I didn't test that because I just test the one VM here. The workload is simple. So with this confusion, I'm just asking, is it a good fit? And so I just step back, like, what do we want in the first place? So like Firecracker is for the serverless computing, for sure. And we don't want a graphic. We just want a computing. Even for the computing, we don't want the training because it will last long. We just thinking about the inference. So we still want it safe, light, and fast. So we check back to this working load, like the platform here. Basically, they are just CUDA or OpenCL mainly. Like even for the ARM NA, it has its own platform, but eventually it will still use the OpenCL driver for GPU side. So maybe things would be easier thinking in another way. Like maybe we create a word CUDA here or word OpenCL, no matter what. So we can create it as the vfio-mmio device. And it's only for the general compute. And the design could be based on the driver API. And then use the vring to transparent to the host side. And so we don't have those concerns anymore, like the memory pin and a huge, complicated machine configuration and the kernel configuration. So maybe, so I think I'll probably be working on it. There's already started the initial work here. Another way is it encourages me is that about the 800 MIG, that it could be used directly by container. So I did some research back there, and I thought maybe I can reuse some idea about the NVIDIA container, but no, NVIDIA container is like mount the host driver into the container image, the container root file system. So it's different with virtual machine scenario. But maybe still thinking about another device type, or like vfio-mmio. No, I don't know. But yeah, I'll keep thinking. So for this whole journey, I'm thinking like some questions like, could we do it? Sure, but should we? That depends. Like here, like VGPU in Firecracker, then it may be a very good fit, like because it's a specific user case for Firecracker. But if we jump out of this scenario, thinking about the ARM, the autonomous driving there, that's a different scenario. Like maybe the workload maybe not that heavy, but we still want some GPU computing here. So, and we still want it like a safe, light first. So this may be a good match. So yeah, so that's totally depend on how you want to use it. So I think for this one, I will still implement it eventually, even not for Firecracker, maybe design a new VMM based on the rust-vmm, like just for some VGPU scenario or AI machine learning scenario. That would be fun, but really need to optimize the code carefully. Or just we discussed earlier, just to use a different device model. I think it's doable. I also did some research here. Some paper from school already implemented it with a different way. Here we just needed to do it with Rust and KVM. One thing is I think the API dependency need to be really careful. We don't want this kind of API here. And I think if it has both ways and we do an overall comparison, would be interesting. I think maybe next year I'll share some update with even with upstream. And the last thing is that yeah, I think I like the rust-vmm Firecracker very much. Like especially for creative device, it's much easier than QOM, if you know what I mean. And I think that's it. So if you have questions, and typing from the chat channel and, or email me. So anyway, thank you so much for your time, and it's really exciting. It's my honor to present here. Thanks.